This is Prelab number 4, empirical formula of a compound. Let's look at question 1. In this reaction, we have 0.3255 grams of aluminum reacting with hydrobromic acid to produce 3.2150 grams of aluminum bromide. Alright, this is aluminum bromide. There are only two elements. And since we know the mass of element aluminum is this much, the mass of element bromine is simply the total mass minus the mass of aluminum. So what we should do is we should simply do this: 3.2150 minus 0.3255, and we get 2.8895 grams. Make sure you have the unit here. Alright, so that's how we deal with this. Again, in this compound there are only two elements, aluminum and bromine. So this is the mass of aluminum, and therefore we can use the total mass of two elements minus the mass of aluminum. We get the mass of bromine. Now calculate the moles of aluminum and bromine. We need to convert mass to molar mass. So this is how we work on this. The number of moles is equal to mass divided by molar mass. Alright, and we'll do this for aluminum. The number of moles of aluminum is equal to its mass, 0.3255, divided by its molar mass, which is, you look it up from the periodic table. Now we need to keep 4 sig figures over here, 0.01206. I'm keeping 2 sig figures. We do the same thing for aluminum. We do the same thing for bromine. We have mass on top. This is mass of bromine on top, divided by its molar mass. It's 79.9 from the periodic table, and we keep 4 sig figures. Alright, I'm gonna just highlight this steps. What's the ratio between the moles of bromine and the moles of aluminum? When you compute the ratio, it's just a division. Alright, that's how you do this division to get a ratio. So the ratio is 2.988, or you can say the number of moles of aluminum, the number of bromine versus the number of aluminum is equal to 2.988 to 1. Alright, okay, so for each mole of aluminum we have 2.988 mole of bromine in the compound. And also, we don't have to keep saying moles. We can also say for each aluminum atom there is 2.988 bromine in the compound. However, you probably notice that this is not an integer. We need to have an integer number of compounds. So what I'm gonna do is I'm gonna use approximation here. I'm gonna have to use a symbol. I think I just use approximation over here. 2.988 is approximately 3. So we have this ratio. And then now what we have is this. In this compound, for every aluminum atom we have 3 bromine atoms. So this is gonna be aluminum 1, bromine 3. In chemistry, when you have a subscript 1, we do not usually write it. And that would be the final answer.